Hey, Owen, this is section 1.3. We're going to start notes for this. I will help you fill in your yellow sheet, the bottom part that we started on Friday, when you come back. But here's what I want you to look at first. This little graph right here. This is the parent function 1 over x, okay? Cool. At the bottom of the yellow sheet, I just had you do, like, graph the function 1 over x minus 3, which was the same thing as 1 over x, except moved 3 units to the right, right? Okay, so these two are the same parent function. Got it? All right, he has a horizontal asymptote at 0, right? Okay, so when we are looking at limits and infinity, we're no longer have numbers here. We're not approaching a number. We're approaching infinity. So this first little box, this one right here is saying as we go forever to the left, as we're going forever to the left. What is this thing approaching as our function goes forever to the left? 0, right? And same thing as we go forever to the right. He is approaching 0, right? Do you see that? Now 0 from the bottom side versus 0 from the top side, but it doesn't matter. They're both 0, right? Okay? You see how that works? So we're no longer plugging numbers in. We're trying to find as we go forever to the left and the right, what's he doing? Okay? Good, good? All right, here we go. Horizontal asymptotes. It is like a little known, like misunderstood fact that a lot of people think that a horizontal asymptote you can't cross through. You can. Like this guy here, right? A horizontal asymptote, you can have a function cross through, right? I don't know. I don't know. You can still cross, no, you can't cross through a vertical asymptote, but you can cross through a horizontal asymptote. Okay? Horizontal asymptotes are just there to show what happens as he goes forever and ever and ever and never and never to the right. Okay? Good, good. Actually, I think you actually can. No, I don't think you can. I don't think you can. Yeah, in that case, yes. In that case, yes. Okay? All right, but you can cross through a horizontal asymptote. It's just talking about what's happening as you go forever to the right and to the left. So, yes, he can cross here, just as long as this guy is like approaching that dotted line. Okay, same thing here. You can cross here as long as he's approaching that dotted line on the end points. Got it? Okay, let's go to example 2. I'm going to skip all the way down. Okay? All right. 1 over x to the nth power. Like, write this down. That's all the way at the bottom. Like, let's say I have 1 over x to the second power. Right? We know that 1 over x looks like these little boomerangy guys, right? Do you know what 1 over x squared looks like?
It's even. Isn't it upward? They're both going up?
Yeah, it's like a volcano, right? What's the horizontal asymptote there? Still 0, right? Anything to, like when we do that, if it's to the nth power, like 1 over x to the nth power, no matter what, is still going to approach 0. Got it? Make sense? Okay, so in that case, all like 1 over x to the third power, 1 over x to the 7th power, all of them are going to approach 0, unless we do this. Like, let's say I do 1 over x minus 3. No, I don't want to do that. I don't want to do that. We'll cross that bridge later. We'll cross that bridge later. But 1 over x to any power is going to approach 0, left and right for a ha. Got it? Okay, let's go to, I'm really breezing right through this. Let's go and do an example. Let's do an example. All right. This is a what kind of function right here? Linear. So if I'm talking about the limit as x goes to infinity of x, right? That's this linear function that goes up at a 45-degree angle. As he goes forever to the right, what's happening to him?
He's getting higher.
He's going forever to infinity, right? Or if you plug infinity in here for x, he's going toward infinity. He's reaching up here, right? What about the limit as x goes toward negative infinity?
Hey, teach, I'm missing some papers.
Negative infinity. He should be there. He's right there. He's right there. We're right in the middle of the page. Yeah.
That's true. Wait,
Okay.
Jacob has a question.
What?
What's the difference between this and like back when we did like the as x approaches infinity, y?
Yeah, very similar. It's just calling it a limit now.
So why couldn't
It's
you
just
say
calling
that
it a
like
limit
day
now.
one?
Because we didn't know what a limit was, and that was just too much. That's too much
Too much
information.
to use.
Too much
we
information.
learned.
Yep, right.
You like little Ray-Bans.
Okay, this guy is a quadratic function, x squared, right? The limit as x approaches infinity of x squared. As he goes forever to the right, what's he doing? Going toward infinity. If I plug infinity in, what's infinity squared? Still infinity. Let's talk about as he goes forever to the These are all what type of functions? They are all polynomials. These are limits of polynomials.
I'm not good at graphs.
Which we had a
Okay.
section for those.
Yeah, that was the first little, like on your yellow sheet, the bottom very left corner. That was all polynomials. He's going to go to infinity or negative infinity. This is a cubic function. So the limit as x goes to infinity of x cubed is
Infinity.
infinity, because infinity cubed is still infinity. What's the limit as x goes to negative infinity of x cubed? Because negative cubed is still negative, right? Okay. X to the fourth, the limit as x goes to infinity of x to the fourth is infinity right here, right? The limit as x goes to negative infinity of x to the fourth is also going to be infinity, because negative to the fourth is positive. Got it? These are all polynomials. They're going to either go to infinity or negative infinity. They're not going to approach Haas because polynomials don't have Haas, yeah? Okay. There we go. This guy. Oh, pretend that you don't know the answer. Let's talk about these. What does 2x to the fifth power look like as a parent function?
One's going to be going this way.
He's going to go like this. Whatever. Something like that. As we go forever to the right, he is going to positive infinity, right? Negative x to the sixth. Do we know that even powers go the same direction? So he is going to look like something like that, right? He's going to end down and down because he's negative and he's sixth power, right? So as I'm going forever to the right, he's going negative infinity, right? Probably.
Like closer together.
Yeah. If we're just talking about like what he's doing on the end, I don't care what the middle bubbles look like. Whatever.
So how do you even get the lower?
Oh,
Depends on what power
so x to the fifth power I know goes opposite directions, right? Odd powers go opposite directions, and the fact that the 2 is positive means he's going uphill from left to right. Okay? This guy is a sixth power, so he's either going to go like this or he's going to go like this. But since he's negative, he's going to go like this, and he's going to probably have some humps in the middle. I don't care what they look like. Down and down. Okay? So let's do like this
How
one.
come x to the fourth?
What do you mean?
It's good it didn't have like any like.
Yeah. So in order for him to actually have bubbles, he has to be like x to the fourth plus 3x squared plus 7x. That's what puts the bubble in there. But actually, x to the fourth in general looks more like a flat tire. He doesn't actually have bubbles in him. Okay?
Flat tire?
He looks like a flat tire. All right. This guy, 2x to the fifth, we said starts down here and ends up here somehow. Maybe he has bubbles in him. As we go forever to the left, he is going negative. He's going to negative infinity, okay? X to the sixth, that's going down like whatever. I don't know, maybe he only has 2 humps. As he goes forever to the left, he's going down, negative infinity, okay? So if there's ever a polynomial, put that down on this paper. Polynomials. You can make reference to example 3 and these guys up here. That's what they look like. If you're evaluating infinities of polynomials, he's either going to go to positive or negative infinity forever for polynomials because they do not have Haas, right? They're not going to approach a number. Good? What?
May go get a drink. Name the game.
Can you wait 2 seconds? Go to example 4. Just wait. Go to example 4. Take a look at this guy right here. All right. We are going forever to the what? To the left, right? Negative infinity going forever to the left. Now, Trevin, when we have a big long equation that has 4 terms like this, I only look at the highest one, right? So I'm only looking at 7x to the fifth. All right. X to the fifth is going to go opposite directions, and he's going to go uphill. So he's going to look like this, and we're going forever to the left. So he's going to go negative infinity. That's the answer to this. We're only look at the highest degree.
Also look a little more to your right.
Right, I know that there's the answer. All right, this one, we're only looking at x to the 8th. X to the 8th is going to go the same way, and it's negative, so he's going to go like this, right? What? I don't know how many humps he is. There, we're going forever to the left. As we go forever to the left, he's going
Negative.
down, so negative infinity there as well. Those are all polynomials. Okay? You just look at the parent function. These are all parent functions. The parent function is x to the 8th power. Negative means he's going down and down, right? Got it? Polynomials, x to the 4th power. We're like rocking right on through these. Okay? Good? Yes? All right. Now we get to these. Are these guys polynomials? In example 5. No, they are what kind of functions?
Regular functions.
Rational functions, okay? These are going to have ha's, maybe, right? So we look at the rules. Rule number 1, rule number 2, rule number 3, I'll put them here, and they're also on your yellow sheet. So we look at n and m. What's n mean?
You should just play blue.
The degree of the numerator. Okay, this guy is the degree of the denominator. Okay, so for this guy, n is 1, because it's the 1 off of the x, 3x to the first, okay? And m is also 1, right? Because it's 6x to the first power. All right, so that goes with rule number, I don't know, did we call them 3? Rule number 3, if n equals m, you look at the leading coefficients.
So it's 1/2.
So it is 3/6 or 1/2. The limit as x goes to positive infinity. I don't even care which way he's going. On both sides, positive infinity, negative infinity, he's going to approach that vertical asymptote of 1/2. One of them from the top. So 1/2 is like here, right? This is going to do this on one side and this on the other side. So no matter what, he's going to approach that 1/2. It's just from the top side or the bottom side, but we don't care which one, right? So this guy, his limit is 1/2. Okay? Let's write out the other rules. What if n is less than m, meaning he is bottom? What's his limit going to be? He's going to sit at 0, right? His limit is going to be 0. He's too fat, he's bottom heavy, he's going to sit at 0. If he is top heavy, he falls over and there is
Not a ha.
no ha, which means the limit does not exist, right? Okay? Because usually he has like a slant asymptote or a hole instead of a ha or something, right? Okay? Good, good? Okay, let's go over here. This guy, what is n? For 6a. N is 2. M is 3. He is bottom heavy, so he is going to sit at 0. So the limit as we're going forever to the left, I don't even care which way we're going. Forever to the left, he's going to approach 0. His horizontal asymptote is going to be at 0, right? This guy, what is n? 3. What's m? 1. They switch that around on you. They tried to trick you, okay? He is top heavy, so this limit does not exist. Okay? Which means he's probably going toward infinity, actually. But does not exist. That's not mine. Yeah. This graph, like let's say I take this guy and I divide it by this guy because he's top heavy, I could technically divide him. It's going to give me another polynomial that is a degree 2, right? He's going to be a second degree. If I take an x to the third and I divide by an x to the first, he's going to be an x squared. So he's going to be a parabola and he's going to go toward infinity. I guess, yeah, we're going to the right. So he's going to go toward infinity. So you can either say infinity or does not exist because technically infinity means does not exist, right? Okay. Ooh, yeah, let's stop there. That was a lot. Okay? We'll do the square root ones tomorrow. I don't know.
I don't know which one.
Normal time.
Are we gonna get a unit circle?
Period 739.
Are we gonna get a unit circle?
Yes,
When?
eventually. Like not for a little while. Like next chapter, the end of next chapter. We'll do trig. We'll do derivatives of trig functions.
Trig will get unit circle. Trig will get unit circle after.
Yeah. Okay. Goodbye, Owen.
Are you sure?